Algebra 1, Unit 5, Lesson 15. We are going to look more into these percent rate of changes that we talked about in the previous lesson. So as of right now, we've got two different equations here that we have learned. We're going to first review our old equation, which is in the form y equals a times b to the x. Okay, so this equation form, we should be able to identify the initial value and the growth factor for each equation. Now, equation 1 kind of starts off a little tricky because we only have one number here. So think about this as 1 times 3 to the x. So the initial value is always this first number. The growth factor always has the x with the number. That's the number we are multiplying to get our next number in the sequence or table or graph, whatever. Equation 2 is a little easier to see. So the initial value here, again, is the first number, which is 2. And our growth factor happens to be the same. It is the 3 that has the x value. And then our last one here, the initial value is our first number, so the 3. The growth factor is the 1/2, which goes with the x. So we just reviewed this one. The a value in this equation is the initial value. And the b is the growth factor, which again, that is the number you multiply to get the next number, okay? We just talked about our new equation, so the a value is still the initial value in this equation. But now our b, which happens to be this whole parenthesis, this still represents b. But to get that number, you have to do 1 plus or minus, depending on if you're adding or subtracting, by this percent rate of change. So if I tell you that we are increasing by 10%, you're not going to multiply by 0.10 because that gets you a smaller number. You have to do 1 plus 0.10 to get the actual b value. And that's what we're going to focus on today. It tends to be the most confusing part of these two equations. So example 1, we have in 2010, the population of a town was 12,000 people. This is our starting amount. The population increased by 30%. 30% written without your percent sign is 0.30. Okay? They went ahead and gave us the equation, which is great. So here's your initial value, 12,000 people. We said that we increased. So the word increase means we're going to add that 30%. So this is your percent rate of change. So we're just going to answer the following questions. What is the initial value? It is 12,000. That's how many people we started with. What is the percent rate of change? It is, you can write it with a percent sign, or you could write it as a decimal without the percent sign. I'm okay with either one right now. And then what is another way to write this equation? They want us to simplify. So this equation could be written as 12,000. And then instead of having the 1 plus 0.3, you can combine it to be 1.3. When you do that, this is now in the form a times b to the x. So the 1.3 is the growth factor. That is what you would multiply by to get the next number. Okay, so we're going to fill out the following table. So our X is 0, that's our initial value. We start with 12,000 people. And you can go back, you can use your equation and change the exponents. Or if you want, you can just take your 12,000, multiply it by 1.3. And we have 15,600, multiply it by 1.3. 20,280, multiply it by 1.3. 26,364. And that's it. That's all you got to do. So we need to know the difference between percent rate of change and growth factor. Okay, let's go ahead and try another one here. So the pond initially had 50 frogs. The population decreased by 15%. So this word decrease would mean subtract. So in the equation here, you're going to see the minus sign and then the 0.15 for the 15%. Our initial amount of frogs is leading out front. So given all this information, let's identify the key features. What is the initial value? 50. That's how many frogs we started with. What is the rate of change, percent rate of change? I would put the negative sign because that tells me we are decreasing. Negative 0.15 or negative 15% would be fine also. Another way to write the equation, so it's simplified. If you do 1 minus 0.15, we are left with 85.85 or 85%. And that's the number that you would multiply by. So what is the growth factor? It is 0.85. It's the simplified number. Okay, so filling out our table, our initial amount of frogs is 50. And then we can multiply it by our 0.85, or we can use our equation and change the exponent. Totally up to you. So if we pull up our Desmos here, we have 50 multiplied by 0.85. We get 42.5. Multiply by 0.85 again. 36.125. Multiply by 0.85 again, 30.70. Now, since we're talking about frogs, if they asked you an actual question, you'd have to round these numbers because one could argue you can't have half of a frog, but for the sake of the math, we'll just keep them the same in the table. Okay, so hopefully that makes a little bit of sense with the word problems here. We're just going to kind of continue with the same idea. Just given the equation, can you tell me if it's growth or decay? And then can you identify the percent rate of change versus the growth factor? Again, it's something we struggle with every year. So you just got to pay attention. All right, so for the first one here, we have 1 plus 0.75. So if we are adding 75%, our numbers are going to get bigger. So this is a sign that it is growth. We are adding 0.75, so that is a clear indication of the percent rate of change is the 0.75. But the growth factor would be this simplified, which is pretty simple. It is 1.75. That's the number you would multiply to get the next number. Okay? So kind of the same idea with number 2, pretty simple. This says minus 0.05, so this means we are decreasing by 5%. So decreasing, decay, pretty clear sign there, right? The percent is the 0.05. Now the growth factor, you might need a calculator, but if you simplify 1 minus 0.05, we are left with 95%. That is the growth factor. That's the number you would multiply to get the next number. Okay? Now the next two are a little tricky because you can't see the percent rate of change. You actually have to work it backwards. So number 3 here, we don't have the 1 plus or minus. This is the B value. This is the growth factor. Okay? Now, if B is less than 1, it means decay. 0.95 is less than 1. Okay? To get the percent rate of change, the trick is to always subtract 1 from the growth factor, and it will tell you what you added or subtracted to get the growth factor. So check this out. 0.95 minus 1, you get a negative 0.05. We decreased by 5%. So you always subtract 1 from the growth factor to get the percent rate of change. Okay, let's look at number 4 here. Number 4, our B value is 1.28. 1.28 is bigger than 1, so this is growth. Since this is already simplified, this is your growth factor. This one I think is pretty easy to see the percent rate of change, but for the sake of the problem, the trick is to always subtract 1. So 1.28 minus 1 tells us that we increased by 28%. Oops. And that's it. Percent rate of change, growth factor. 2 different things. Okay, these were supposed to be done in small groups, and I was going to walk around the room and check, but for the sake of this video, we will do it together. So problem 1, the turtle problem. We have an initial population of 750 endangered turtles. They are going to triple each year, okay? So this phrase tells you exactly what to multiply by. Triple means to multiply by 3. This is a growth factor, not a percent rate of change. So the equation we're going to use is the A times B to the X. We know what to multiply by, okay? So to step you through this, what is the initial value? We start with 750 turtles. Do we know the growth factor or a percent rate of change? We know the growth factor is 3. So the equation is 750 times 3 to the x. You don't need to add 1 to it because then you're multiplying by 4. It's no longer tripling. Okay, you already know you're multiplying by 3. That's it. Easy peasy. Once you have your equation, you can just use the equation to answer the following question. So 750 times 3 to the 5th. Type that into Desmos. And we have a lot of turtles. 182,250 turtles. Okay. Problem number 2 says that the population of Petersburg starts at 20,000 and it is growing by 13% each year. This is a percent. It's growing, that means to add. So we are using the equation 1 plus r. They didn't tell you what to multiply by, they gave you a percent rate of change. The initial value is 20,000. Do we know the growth factor or the percent rate of change? We know the percent rate of change is 0.13. So our equation is going to be 20,000 times 1 growing plus 0.13 to the x. Now you could simplify that to just say 1.13 if you'd like. You don't have to. But once you have the equation, you can use it to solve for the 10 years by plugging 10 in for x. So 20,000, 1 plus 0.13 to the 10th. And you just got to type that straight into your calculator. 1, 2, 3, 1 plus 0.13 to the 10th. 6, 7, 8, 9, 1.34. So the difference between giving a growth factor and a percent rate of change. All right, 2 more, and then you guys can do your independent practice here. So problem number 3 says that a house is purchased for $150,000 in 2002. The value of the house depreciates at a rate of 7%. This is no longer accurate with our housing market, but we'll go with it. So the initial value of the home is $150,000. The word depreciate means to decrease, so we are subtracting. They said by 7%, so that is a percent rate of change. If you want to include the negative, go for it. So we're subtracting 0.07. I noticed on the previous lesson, you guys are still struggling with this. 7%, you need a 0, then a 7. If you don't put the 0, then it's 70%. Very different number, okay? 0.07. All right, so our equation then would be 150,000. We are depreciating, which means to decrease, by 0.07 to the x. Once you have your equation, you can use it to find how much is the house worth in 2013. So from 2002 to 2013, that's 11 years. So we are going to plug in the number 11, not 2013. And type that into Desmos. So according to this problem, the home is now only worth $67,515. Womp womp. All right, the last one here, problem number 4, says that we have a population of 100 frogs, and it is decreasing each year. They're telling you that only 2/3 of the frogs remain. So this is the exact amount that we are going to keep. This is your growth factor. The initial value is 100 frogs. We are keeping 2/3. Now, if it said that you are losing 2/3, then you would have to use the number 1/3 because that's how much is remaining. But they told us exactly 2/3 is remaining. Okay? So our equation doesn't need the 1 plus or minus. We just have 100 frogs. We're keeping 2/3 of them, so multiply by 2/3, however many times, to the x. Okay? Once you have your equation, then you can use it to plug in the 6. So on Desmos, you'll type in 100 times 2/3 to the 6 and see what you get. 8.77. Okay, hopefully this was a little helpful to clear up the difference between growth factor and percent rate of change. You do have an independent quizzes practice, so you can go to joinmyquiz.com and type in the following code, or there is also a link on Canvas. You can just click the link. You have as many attempts as you want. Please make sure you screenshot your score and I will give you whatever you give me. So 10 out of 10, 5 out of 10, it's your choice, it's your life. I just live in it. All right, let me know if you guys have any questions.